Okay, so for this problem, we want to find the equation of the tangent line for the function f of x is the square root of x at the point 4, comma 2. And for this section here, we need to find the derivatives and slopes of tangent lines using the limit definition. So our limit definition is going to be the limit, and you can either use h or delta x goes to 0 of f of x plus delta x minus f of x, all divided by delta x. So for this problem, the slope of our tangent line is going to be the limit as delta x goes to 0 of the square root of x plus delta x minus the square root of x divided by delta x. And you'll notice this is an indeterminate form because if we substitute in delta x equals 0, we'll just get 0 over 0. So for limits of this form here, we want to always use our conjugate. So we multiply the top and bottom of our expression by the conjugate, square root of x plus delta x plus square root x. And again, we always do the same thing to the numerator and denominator. Extend that fraction bar. All right, so now we're going to multiply, and we're going to have the limit as delta x goes to 0. Our first term is going to be just x plus delta x. And then we're going to have plus the square root of x, square root x plus delta x, minus square root x, square root x plus delta x, minus x. And we'll notice that those middle terms always cancel out in this process. And for our denominator, we're just going to have the product delta x times the sum square root of x plus delta x. All right, further simplification, we'll notice we could cancel out our x's in our numerator as well, leaving us with just a delta x. So this is going to be the limit as delta x goes to 0 of just plain delta x over top of delta x times the sum square root x plus delta x plus square root x. And those delta x's divide out and cancel, leaving us with a 1. And we now have a limit that we can calculate directly. And we'll do that in the next step. All right, so now we can take that limit and replace our delta x with 0. And that gives us 1 over the square root of x plus another square root of x, which of course is just 1 over 2 times the square root of x. So for any point in our graph where it's defined, the slope of our tangent line is 1 over 2 square root x. Now for our problem, we're looking at the point 4, comma 2. So in that case, the slope of our tangent line is just equal to 1 over 2 times the square root of 4, which is just 1/4. And now to find our equation for our tangent line, we can use our point slope formula, which we all know is y minus y1 equals m times x minus x1. So for this problem, it's going to be y minus our y value, which we know is 2 given to us. Our new slope we found, which is 1/4, x minus 4. And then if we distribute and combine like terms, this is 1/4 times x minus 1. And then if we add 2 to both sides, we get y is equal to 1/4 x plus 1. And that is the equation for our tangent line at the point 4, comma 2 for the function square root of x.